what is the meaning of artificial intelligence. It is really a very fast-moving space. What it means is to have a system that can function independently and intelligently without the need to have any learning capabilities. And the easiest way to understand artificial intelligence today is to put it in the context of the human. After all, a human is the most intelligent creature we know so far. So today, I'm talking to you I'm talking and you are listening. And this is a domain itself in artificial intelligence called speech recognition. And we are already using it on a daily basis. You are talking with Siri and you are talking with Cortana. The same thing. We are able to communicate, to read and write email through text. And this is basically a domain itself in artificial intelligence called natural language processing. And we're already using it on a daily basis through a Google search or basically through extracting a meaningful information from PDF file, from structured data or unstructured data. So in the domain of artificial intelligence, we see now a new revolution, means that 5G technology. 5G technologies, it's going to make our world more interconnected. Means that today is not only inside the industry, it will be interconnected across all the industries, from connected homes to self-driving cars to basically move everything into the factory using a robotic solution. And I think most of you are aware with the crisis that happened in oil and gas prices in 2014. And this is basically pushed all the organization from international oil companies or national oil companies to look how they can become more agile on producing energy. And this is just a result from a survey that has been done by PwC, is saying the global energy demand is going to be increased over upcoming years. Despite the employment level will remain low. What is this telling us? It's telling us that we have to do more with less. We have to find a new way of doing things differently, efficiently, to come up with a very competitive energy solutions. So that's why today we see these enabling technology, these buzzwords that you are hearing today about artificial intelligence, cloud computing, is totally changing the way how we are ingesting our data, how we are doing interpretation for our data, and how also we use artificial intelligence to provide the recommendation for a geologist, for a driller, for a geophysicist. So it is basically having this enabling technology to work hands to hands with our domain experts to accelerate and automate the repetitive task, not to replace the people. So from that perspective, if you put it into context of oil and gas, because today AI can be deployed everywhere. So in oil and gas, you see there is 4 main things: drilling, production, reservoir characterization, and field development planning. So for the drilling and production, it was easy to apply artificial intelligence. Why? Because you have a huge amount of data. You can listen to this data and come up with a solution for predictive maintenance, for example. But if you are talking about subsurface characterization or field development plan, where you don't have really a huge amount of data everywhere, you have vast amount of data, but it's very specific area under the subsurface. And to be able to apply artificial intelligence, you have to come up with very complex learning concept to the algorithm to understand how the faults it's look like inside the seismic survey. So that's why today, most of the AI project start with a huge amount of proof of concepts. There is almost more than 95% of proof of concept that is going on parallel in different organizations. But guess, only 2 to 3% of this, it's getting the minimal viable product. And the value generation of this is just only less than 1%. And when you move forward for sustainable, scalable product is less than 1.5%. So that's why you cannot apply artificial intelligence in anywhere. You have first to understand what is the business goal, why you need to apply AI. Identify the problem that you need to apply AI for and you want to overcome it. And then after that, it will be easy for you to focus on it. Build the team and bring your data, all this together. Then you will be successful to implement and scale your AI projects. Okay, I know most of you are not coming from oil and gas, so I will try to make it easy for you to understand. So in front of you, this is the fundamental subsurface workflow. Means that from any company that they start to do exploration, development, and production to the refineries, to the distribution of the fuels. It is basically a huge number of months. You start from 30 months and plus. Any investors want to say the right concessions to go and select just the right asset and get the first seismic files, it takes him more than 30 months. So when he has this data with him, he will start to do a seismic processing. It takes him more than 12 months just to do a processing of this data. Then when he has it, he has to do interpretation. He has to bring the geologist, the geophysicist, to make sense of these images. It took him at least 4 months. And then he has to build his model, because you are dealing with something under the earth that you cannot see it. So you have to model it. So to build this model, you need minimum of 4 months. And then you need to simulate that model, because this is not going to be the same reservoir you need to produce. So you need to make sure this is economically viable for you to produce the oil. And yes, after all this, you extend and give and incorporate all this data, and you spend more than 3 months to understand, yes, I am going to drill or no. And this is a very good problem for artificial intelligence to solve. It's how I can dramatically reduce the turnaround time of these 30 months and a half. And what I'm going to show you now is how we've been very successful on applying artificial intelligence across this subsurface domain. Okay? So let's start with the seismic processing. So we say is 12 months and more. Okay. In the seismic processing, if you have an application that is starting to work in specific traditional workflow, that means you have logs of this application. So that means you understand how the conventional way of working. And when we try to look how we can apply AI to accelerate this 12 months and a half, so we say, okay, let's make sure that to split into 3 main sessions. First is the parallel computing. This was very easy. You just move everything to the cloud. You have unlimited access to holistic computing and easy for you to apply. Second, the serial computational means that I have application that has been coded into specific language. So I deconstruct this application and I can move it easily into microservices using cloud computing. Third one is the human interactive on the daily basis. So apply analytics, be able to do a lot of things, then you get an application that you can easily extract and select all the parameters automatically without having for any intervention during the seismic processing. So for that, this is a real example from one of the seismic file. This is the image. This is how the earth is look like. And what you see in the blue is the salts. You need to pick the salts inside this image. Historically, this kind of interpretation, to just pick the salts of the seismic file, it took 4 engineers to work 4 weeks to come up with these results. But at the end, it's an image. So if you train a convolution neural network to understand how the fault is look like or how the salt is look like inside this image, you can get up with this result. But the only difference between these two is the first one, it took 4 weeks to come up with this result. But in AI-driven salt picking, it took only 4 hours to run. So this is just to give you an understanding where we are moving in oil and gas. Okay, so this is the 13-month that we talk about. So now using this technology, we will be able to reduce it basically into 2.5 months. Okay? Because we are using this kind of artificial intelligence things. Seismic processing. In your left side, this is again image. An interpreted image. And the easiest way is to train an algorithm to understand how the fault is look like. And in the right-hand side, it is a machine learning deep convolution neural network that has been trained to pick the faults. And the only difference between that is when you have artificial intelligence move into this, not to only create more faults, is to enable the entire workflow. Means that you create more faults, you come up with more simulation models. It will help you to get more and more insight results. And this is a blind test that has been done, which top domain experts say, my team has to do this one in 1 month. And if you give it to artificial intelligence, combine with the team together, you can do it only in 1 day. So this is where we are going and heading in oil and gas perspective. Okay. So another example of that is today, a lot of people, they say, okay, artificial intelligence is going to take our job. No. It's going to take a repetitive job. Means that the first run has to go to the machine to finish the repetitive job. And then when you have an information that you cannot extend further cognitive environment, you give it to your domain expert to extend that further interpretation. Okay. This is what we do in the well bore, we name it the well data. So this is one of the clients, they say, okay, I have 150 kilometers of data that I have been already acquired, so I don't want to spend a huge amount of money to go and see I'm going to drill where or no. I have already 60 wells. How I can learn how the subsurface structure will look like from only this minimum data. So the first thing is to do is to train an algorithm to see what is the good data versus bad data. And when it's trained, you go and tell it, okay, you go and sieve all now this information that you have and give me the result based on what has been trained with the confidence. So it means that you can do bad data quality check on the fly, you can come up with uncertainty, and you can even make this line with the seismic well tie, we name it. So that means you understand the structure model only from the data. So, and basically this means that you are reducing the weeks or the month into kind of weeks. And this is the way how artificial intelligence is moving the industry. 13 months, 9 months, 2 months, 4 months, the traditional workflow. Combine all these together, it's easy for you now to come up with the solution, can basically take all this together automatically and bring you the entire workflow and different scenarios. Before, if you have a company and you ask, they have only one static model. Despite they know there is a lot of uncertainty inside that model. Why? Because they don't have the capacity to do this one. You have a huge amount of dynamical data that you cannot process as a human being. You have to give it to the machine to help you to enable the entire workflow. So the conclusion of that is we start with 30 months plus. We will be able to connect all these together to reduce the turnaround time into 8 months and half. And we are currently working in Silicon Valley in the Software Innovation Center of Schlumberger to reduce even this into 2 months and half. And any organization understand now the value of AI because it reduces the time, which can be easily converted into a dollar sign. So this is my summary slide. We are saying now, using a convolution neural network or a computer vision, we can basically reduce the seismic processing and seismic interpretation into 80%. We can automate the petrophysics workflows up to 90%. And we can combine all these together to combine the uncertainty from your static model to the dynamic model and come up with thousands of multi-realization instead of hundreds. And then at the end, you have unlimited access for the high performance computing to do reservoir simulation. So you can come up with thousands of reservoir simulations run. So at the end, what I want to say, AI is the truth. We are done with the proof of concept from E&P or upstream or oil and gas. We have seen this is a reality. What we need to do is to embrace this technology and try to focus on our digital transformation strategy and find where of this application can accelerate my return of investment, can help me to produce more oil rather than only just drill more wells. I need to optimize my underperforming wells. And all this information has to come together in one ecosystem that can be open for any organization to be able to have all this information together. So with that, I would like to thank you. I tried all my best to make it more simple, and I hope that I added value for the conference. So thank you very much. Thank you.